Hello, I'm Philip Muggleston, and in this series of videos we're covering the predictive capabilities native to SAP HANA. In this video we'll finish our tour of data preparation and initial exploratory data analysis by looking at outlier detection using the IQR test, IQR meaning interquartile range. It's also commonly referred to as Tukey's test, as it was developed by an American statistician, John Tukey. We saw in the previous video how we can work with the variance test to identify outliers. However, the variance test is impacted very strongly by the outliers themselves, whereas Tukey's test, or the IQR test, is more sophisticated and it's more robust. It's much less likely to be biased by the outliers themselves. So let's take a look at our data set. We saw this already in the variance test example. We've got about 150 customers and we have the new spend value for each of those customers. And what we'd like to do is identify outliers, either because there may be errors in the data, or it may be that they're indicative of fraud, or they're just things we want to know about to better understand the data before we perform further data mining and analysis. So we can see the new spend value, and in fact if we perform some quick analysis, if we take the ID and the new spend, again we can see the values, the range of values we've got, but actually we can quite easily show a box plot. And effectively Tukey's test is the theory behind this box plot. So what does it actually mean? Basically what happens is all the data points are taken into account. The arithmetic mean is calculated, which is here about 3 in the middle, and then the range between the first and third quartiles, which you could also say is basically between the 25% and up to 75% of the data. So that middle range where most of the values fall is what we see as the box, and the size of this box is basically the IQR, the interquartile range. And then what Tukey said was if you then take this value, the range, multiply by a multiplier, typically 1.5, so we take this value, multiply by 1.5, move upwards, you then draw a line. Do the same below, take the value, the IQR, multiply by 1.5, do it below. Any value that falls outside of these lines can be identified as an outlier. So that's how it identifies the outliers. It's using a slightly more sophisticated approach than the variance test. So how do we actually do this using the PAL? Well, it's very straightforward. It's almost identical in the way that you code this to what we saw with the variance test. So we have your input data, you have a results table, which this time shows you the Q1 and Q3. That's the first quartile value and the third quartile value. And also, you get a table which identifies which of the observations, which of the customers are outliers based on the analysis performed. We use the IQR test as the specification for calling this capability, and we'll call our function PAL_IQR. That's our choice. So let's run this code to set it up. We then need to specify our source data, input data. We're using basically the same approach as we had for the variance test previously, and we set up the parameters. There's only one real parameter we need for the IQR test, and that's the multiplier, which normally it's 1.5. However, in some cases you might want to increase this. For example, if you've got more than about 36 data points, then you may want to use a value of 2. And sometimes you may want to go even up to a value of 3 if you're looking for absolute extreme outliers. So we'll stick with 1.5 for now. So let's run this code to set up the tables and the parameters. And then we're ready to go and run our analysis. So let's run that analysis. And if we refresh our tables, we will now see we have an IQR results table. Let's preview that, where we can see the values for the Q1 and the Q3, the first quartile and the third quartile value. And if we go back to that analysis we just were doing on the customers table, 2.8 for Q1, 3.3 for Q3, you can see that's where the box, so it's 2.8 and 3.3, that's basically the limits of this box, and the IQR is the distance between the two. So that's just a bit of extra information for us. What we're really interested in though is to see which are the outliers. So if you now preview this table, again we see, as with the variance, we get all of the observations put back with a flag saying 1 or 0. If it's 1, it means that's been flagged to be an outlier. However, a slightly easier way to approach this, if we go back to the code, might be simply to join the results, the list of IDs with outliers, onto the original data so we can see the values more easily and maybe add other data. So if we just run that, we can see that Tukey's test gave us 4 different IDs which it identified as outliers, 3 at the top and 1 at the bottom. So maybe we could just go back to our box plot, and yes, we see actually the box plot's done exactly the same thing. It's incorporated the same test. It's found the same 3 at the top and the same 1 below. So effectively we have the ability with the PAL to do as we want calculation and identification of outliers. However, we can go a little bit further because the standard box plot graphic there is using this multiplier of 1.5, which is the standard. But for example, we wanted to go to slightly less outliers, so we want to increase the range, the multiplier, a bit. So multiply the interquartile range by 2. We can simply set the value to 2, and in fact we won't do it there with the insert. That should be 1.5. We should update it here. So here we can see we set the value to 2, and then we clear out the tables, run our analysis again. When we set it to 2, we see that this time we only get 1 customer identified, and it's yet again the one with new spend of 4.4. We can see here it's that one at the very top, the one that's 4.4. So we have a lot of power and we have a lot of control in terms of how we approach working with the interquartile range test using the PAL in HANA. And of course, this is HANA. You want to point this at a very large data set. It will perform this analysis very powerfully, very, very quickly, and you'll get a very fast response in terms of what those outliers may or may not be, and use that as part of your initial data analysis and as you prepare data for other analysis. So that completes our look at the IQR test.